Testing, testing. Okay, welcome to Programming Rainbow. In this video, we will continue on the series of Minesweeper in C and SDL3. This is the 12th video, so if you're just following along with this video, you can go to github.com, Programming Rainbow, and this is called Minesweeper C SDL3. You can git clone this repository, move inside the directory, and if you did just clone this directory, you're going to want to change this src folder. This is going to have the final code in it. So since this is the 12th video, you're going to want to delete this directory. You're going to want to copy the 11th video directory and rename it src so you can follow along with where you are right now in this video. Okay, I'm just going to show the final code real quick so you can see the game, what we're shooting for. So this is Minesweeper. This is been around on the old Windows systems for a long time, all the way up to like Windows XP. I'm not sure if it's still there or not. But anyway, it's all about trying to be able to figure out where the mines are. This one means that one of these squares touching this one is a mine, and it was that one. I just unlucky clicked on it, and we got a sad face. The time stopped, and this is indicating how many mines. So we had 8 mines on this board. So if we click it again somewhere, there we go. So this is a mine right here. I can indicate it, and I know this is not. Yeah, I can indicate that one. That is definitely mine. This is a mine. This is a mine. That gives me 5. So basically I have a couple more to find. I know these are all not mine. Okay, so this guy right here, that's a mine. Now we have 6. We need 2 more. This is a mine. This is not a mine. This is not a mine. So this guy right down here, there is one. You don't need to indicate these mines. I'm just doing that. I'll try to leave the last one off. Oh, there we go. We won. So you get the idea. That's the game. That was 50 seconds, 58 seconds that it took. And you can reset it by clicking the face down here. And you cannot lose or win on the first move. Okay. So I'm going to show you where we left off with video, what was it, 11? The last video. So in the last video, we actually have the board is basically the working game. I'm going to cause it to end right here. And this totally works. Everything's fine. The game is fully functional, except we have no mines indicator here, and we have no time indicator here. So what we're going to do in this video is we're going to make this clock right here work. Okay, let me just exit this and make sure I'm still live on YouTube. That looks good. Okay. Just pull up my notes real quick. We're going to be in the clock one, and we're going to add a couple things. So let me just show you what's happening in clock. So right now we have this setup where we're loading 2 images. It's over. This is one of them, and the image back. So we have this image that's being loaded, and it's broken up into all its pieces with the source rectangles. And we also have the image back, or the clock back, whatever I called it, is also being loaded. So those 2 images and the source rectangles for them. But we're not actually displaying anything. We're just displaying this first image right here. So in here we have the rectangle set up and all that, but this is us loading the digit back, and then this is when loading the digits themselves, which is the image we just saw. So down here in the draw, we are just drawing the 0 for both of them. So the 0 for the back, there is a color version and a black and white version. So 0 for this will means the color version, that's fine. But for the digits, it means it's going to be the 0 digits. So we're just displaying 3 zeros. We've already set this up. So what we're going to need is this information right here. We're going to need to know what that digit should be for each one of the 3 slots, or each one of the 3 digits that we're going to display. So I'm going to open up the header file, and we're going to add a couple new things to it. Hmm. Oh, sorry. I'm looking at my notes and I'm looking at the wrong video. I'm looking at the notes for the last video, not this video. And just a little hiccup there. We'll change it. Okay, there we go. So basically, we have these 3 digits that get displayed. Let me just show you real quick. I'm just not gonna recompile it. Oh, yeah, I am, because I'm gonna show the current. Okay, so we have these 3 on both of them. So what I'm going to do is just going to make an array of unsigned ints, just like this is a 2D array of unsigned ints for the front and the back board array. For these clock, I'm just going to say each one of these, this is the 100 seconds, this is the 10 seconds, this is the 1 second. So I have these 3 spots. So I'm just going to have an array of 3 unsigned ints. That's how I'm going to do that. So I'm going to call them digits, and it's just going to be an array of 3, and they're unsigned. And then I need to keep track of the time. So I need to know what's the seconds, what's the time in seconds right now. And I'm also going to be using SDL. I didn't pull up the, what is it? SDL get ticks. Let me just pull it up. I forgot to pull it up beforehand. Something like this, SDL3 get ticks, the function. And this is different than the SDL2 version, because the SDL3 version is using uint64s instead of uint32s. And I believe it still rolls over the same. I haven't looked really close into it, so I'm going to check for rollover. But yeah, so basically what I'm going to do is grab the time, whatever it is, and 1,000 on top of it. It's in milliseconds, so 1,000 on top of that will be a second from whenever I grab the time. And this get ticks is time for when the actual program first started. So if 1,056 ticks go by before I start the game, or if I reset the game at that point, that's going to be my initial time that I grab in ticks. And then I'm going to be looking for that time plus 1,000 for 1 second to have passed. So I'm going to be using this get ticks, and it's just returning a uint64. So that we're going to put that here. And I'm also going to keep track of just the time in seconds. So this is going to be unsigned for the seconds. And then when we get the ticks, I'm going to call it last time. And that's going to be uint. This is a type that is part of SDL, this uint64. This is defined in the SDL library. It's defined right here, actually, from SDL3, SDL standard include or something like that. I'm going to call this last time. Okay, so that's all we really need to add here. I'm going to close this bottom. There we go. So the first thing I want to do is just actually display the display correctly, because right now we're just telling it to display zeros. So what I'm going to do is I'm going to create a function that's called clock update digits. So the point of this function is going to be in this header file right here, we just made these digits. There's 3 slots basically that each have an unsigned int. The left, the 0, if we index this with 0, that's going to be our 100 slot. If we index it with 1, that's going to be our 10s, and index it with 3, it's going to be our 1s slot. If you understand, if it's 900 seconds, 9 will be in the 0 index slot. So we have this. So I want a function that's going to take whatever the seconds are and create it into this array of unsigned ints. Okay, so I'm going to call that clock update digits, and I'm going to put it right below the free the clock free function. So we have clock free right here. And there's probably some really elegant way to do this, but I'm just going to do it a basic way, you know. So this is going to be clock update digits. Construct clock C. Okay. And the first thing I want to do is I want a default. Okay, so I don't actually want to put a 0 in a spot unless it's been preceded by a number. So let's look at this digits real quick. So that's 0 is there, but what if I have what if I'm on the first second? I don't want it to be 001. Instead, what I want it to be is this guy over here. This one right here, I believe, is the 11th. Yeah, this is the 11th digit. I want to use the 11th digit. So if I have, if I'm 1 second into the game, I want this to be displayed in the hundreds, this to be displayed in the tens, and then 0 or 1 or whatever it is in the 1 slot. So right now we're displaying this digit in all 3 of them, but I actually want to use this if, you know, if the number is a smaller number, you know, as a placeholder, I want to use this. So this is number 11 right here. Okay, so this is 9, this is 10, this is 11. So what I'm going to do is I'm going to just make that the default. I'm just going to call it default digit. Okay, and then I need the seconds. And the reason I'm storing these in a local variable because I can change them. Well, on the default digit in my original code, I was changing it. I'm not actually changing it now, so I kind of don't need this. I could get rid of it and just put the 11 in there directly, but I'll just leave it for now. So this is going to be C. So I'm just holding whatever the seconds is because I might be mutating it inside of this function. Let's please go by. I'm going to be mutating inside this function, but I don't want to mutate the original one. So if hold on. So if say we have 115 seconds go by, I'm going to be kind of mutating the seconds number to get the 100 spot, the 15, the 10, the 1 for the 15 slot, and the 5 slot. So I don't want to affect the original seconds that have gone by. So I'm just holding a local variable right there so I can play around with it. Also, I can't count over 999 because I only have 3 slots. So anything over 999, I'm just going to let it be 999. So that's the first thing I'm going to do. I'm going to check that. So if the seconds has gone over 999, I'm just going to set it to, I'm going to set the local variable to 999. Okay, very basic thing, just because you could be playing the game so long that it does go over that, and you know, I need to take care of that case. So now, basically, if we have a number that is bigger than 99, that means something is in the 100 spot, okay? Which is going to be the first index. So I'm going to check that now. Now I'm just going to check the local variable seconds. It's not really matter for this one, but later on it will matter. So if it's bigger than 900, what I want to do is I want to get the slot get the one that's in the 100 slot, okay? So I'm going to divide it by 100. So imagine if it's bigger than 99, it could be 105. So if I divide 105 by 100, I'm going to get 1.05. But if I cast it to an unsigned int, it's just going to be 1. So that's what I'm going to do to get the 100 slot. I'm going to say C, sorry, it's digits. I'm filling up the digit slot. And I want the hundreds, which is going to be the first index for me. And I'm going to cast this to an unsigned. So I'm going to take the seconds and I'm going to divide it by 100. And I can't remember if it complains about this. I'm not going to put the 0.0 to turn into a double. My compiler may complain about if it's integer division or not. I actually want it to be integer division, but if it does complain, I'll just add the double anyway. But we are casting this, so it doesn't matter in the end. Okay, so that's if there is something in this slot, if there is something in the 100 slot. But if there's nothing in the 100 slot, then we want that default. We want that default 11 up here, the default digit. So I'm going to say C digits equals a default. Now I'm wondering if we can we could turn this into a ternary, but it might look a little messy. Second is already unsigned. I kind of want to see if I can turn this into a ternary without it complaining. So let's try this real quick. So the ternary, we need the seconds bigger than 99. And then, so if it is bigger than 99, we are doing seconds minus 100. And that should already be unsigned anyway. And then else, it's going to be just 11. I don't even need to mess with this. I mean, I could just put default. It doesn't matter. I'm just going to try 11. I'm just going to, so I'm going to forward declare this, and I'm just going to try to compile it, even though it's doing nothing. I just want to know if my compiler is going to complain about this. Just curious. Yeah, I think I'm just going to push forward that whole idea then. Because this is more concise than this up here. And we could do the default. If I'm not going to use this, I can get rid of it. Yeah, I'm going to get rid of this. I'm going to simplify a lot of this. Because this whole block here is basically that one ternary. And I could do the same with this, you know, if I wanted to. I could say, I could put it up here even. I could say seconds equals if it's bigger than 99, it's going to be 99. Else it's just C seconds. I mean, we could do that too. Why not? Okay, but anyway, this is taking care of the 100 slot or whatever. So now we need to deal with the tens, decimal position, or however it's called. So I'm kind of want to do the exact same thing, except on this one, I'm going to divide it by 10 first and then get the modulus of 10. So this one I'm dividing by 100 because I'm only care about the leftmost digit, but this one I'm trying to get the center digit. So I'm going to divide it by 10, but then that's going to give me the 2. So then I'm going to use the modulus 10 on it to basically isolate that center digit. It's going to be a little similar. Let me just grab this. See if we can get away with this again. If it starts looking too messy, I'm just going to break it up into if statements because I like it to be readable. But so on this one, I'm going to go over I'm going in if it's over 9, not 100. And this is going to be the 1 slot. And so this one, we have this kind of 2-stage going on. First, I need to divide it by this one. And then I need to get the modulus of 10. Let's see if it complains about that one. Okay, cool. Sorry, my notes are completely different than this. I'm just kind of messing around. Watch, it's just totally not work when we try to display it. So we still have the default 11 on here. So the last one, I'm just going to do the modulus 10 on it. And that should give us the 10's position one. I'm just going to yank this again. And now we're in the second position. On this one, we don't need to run this ternary at all. On this guy, what we're doing is that's all we're doing. Very simple. So that is our update. That's quite a bit smaller function than I had before. But we can see pretty quickly if this is going to work. I'm just double checking I haven't missed something. I think I've got this all right. So what I'm going to do is I'm going to run this function. I'm going to call this function from the new function up here. At the bottom of the new function, I'm going to run this. And I kind of set it up. This will also be run on resets as well. And anytime the seconds have changed, it'll be run as well. So it only needs to be run anytime the seconds have changed. So when they're first set up, when they're reset, or when 1 second is going to 2 seconds, but it doesn't need to be run every other time. So if we're running at 60 frames a second, say, it only needs to run when the second has clicked over one time. Update digits. And this is just C in here. So that's going to call that to be updated, which is great. And then down here, what we're going to do is right here where this is a 0 in here for the digit, we're going to say C digits. And then we're going to put, since we're indexing from 0 to 3 here with this I, we're just going to put I in here. And that's going to go through and see whatever we had for each one of those. It's going to do it for each turn of this loop. So hopefully, let's see, seconds should be 0 right off the rip, right off the bat. So hopefully we're not updating anything yet, but hopefully it should be the placeholder character, and then a 0. So let's run it and hopefully that works. Okay, yeah, that's perfect. That looks exactly placeholder 0. So now we just need to kind of, make this work now with the time. Or it's a stopwatch. But I have two more functions we need to do. We need to do a reset function that gets the new last time and sets seconds back to 0 again, and calls that clock update digits. But I also need an update function too. So I'm going to put these above, since logically they're calling that. Or sorry, I'm going to put it below, since logically they're calling this one. So the reset is pretty simple. It's just void clock reset clock C. So this one is really simple. Basically, we're just getting we're getting we're setting our last time to whatever the current SDL ticks are. Equals SDL get ticks. This is a void. There's no parameters to this one. And we also need to set the elapsed time. Sorry, not last time. We need to set the seconds to 0 as well. And very lastly, since we've changed what the seconds are, we need to call this clock update digits to set that array of the 3 digits correctly now based on how many seconds have passed. So I'm just going to call that function from right above. And that is the update, the reset. So again, I just kind of want to explain what's going on here with this reset. So if I'm trying to keep track of the time, let's say we started the game and now we hit reset, and get ticks is counting ticks since I very first started the program, not since any reset happened, just I very first started the program, right? So if like 1,124 ticks have gone by when I click reset, I'm going to have this equal last time, right? And my seconds are going to be 0. So I'm saying, right, this is seconds. So when is 1 second going to pass? Well, 1 second is going to pass when I take last time and I add 1,000 to it, right? If this is bigger, if this is, I'm doing this backwards. If SDL get ticks is bigger than that, right? So if I take whatever this last time was, which is 1,124, I add 1,000 to it because this is my 0 second. My 1 second is going to be 1,000 milliseconds after this. So I'm going to take this, add 1,000 to it, which will give me 2,124. If I now call get ticks and it says I'm at 2,350 or something like that, right? That's bigger than this. So 1 second has passed, right? And then what I'm going to do is I'm going to take the last time. Now we don't care that if it's not exactly 2,124, it could be 2,126 or 27 or 30. It doesn't have to hit it exactly, but it's fine. We'll still be on the correct time because then what I'm going to do is I'm going to update last time with 1,000. I'm not going to do it by ticks. I'm going to update it by 1,000. So now it'll be saying, right, now we're at 2,124. Even if the ticks actually said we were at 30, I don't care. I'm saying the next time is going to be this last time, again, that's reset, is going to be 2,124. It's always going to be that 124 no matter what, because I'm just adding in exactly 1,000. Okay, hopefully that makes sense, the logic of what I'm doing here. We are going to check for rollover as well, because it is a massive unsigned int, this 64-bit unsigned int, but I still think that you have to check for rollover, so I'm going to do that. So this is the reset. So all the reset's doing is saying, hey, what's the last time now that we're going to call 0 seconds? And then every time I update my time, I'm going to check it against what this last time was plus 1,000. And anytime I change the seconds at all, I'm running this function up here. Okay, so let's now do what is the actual clock update. Struct clock C. So this time what we want to do is we're doing what I just described above. We're checking to see if the time now, since we're running this update function, has been 1 second past when it was set last time. So I'm going to have some local ones. I'm going to get the current time, and I'm going to get it from get ticks, and I'm going to call it current time. And I'm going to have a lapse time here. Not sure what I'm using a lapse time for. Okay, I'm using the lapse time because I'm checking for rollover. So I'm going to set two local variables here, both unsigned 64-bit ints. So that's uint 64. This is again is the type out of SDL, and I'm going to call it current time. So that's the time whenever I run this function, basically. Ticks. And then I want the elapsed time too. I'm creating this because I'm checking for rollover. And this is just going to be 0. Okay, so the very first thing I want to do, like I said, is check for rollover. So how do you know if rollover has occurred? So if let's say I can only count up to 100, yeah? And I'm using an unsigned int. If I can only count up to 100 and I'm using an unsigned int, when I get to 100, it's going to roll over back to 0 again. It's going to go like 99, 0. And so how do I know a rollover? Well, if my last time is 80, and then I check it again, and I'm looking for whatever the, like when I check the time again, when I go get ticks again, it needs to be bigger than 80. It needs to be bigger than 80. What happens if I check it and we're at 99, right? And we're going to have this rollover if we go any further. And now 2 ticks have gone past, and I go and I run SDL get ticks, and now it says it's at 1. Well, 1 is smaller than 99, so a rollover has occurred. So if my number is not larger than my last time, a rollover has occurred. Okay. So that's what we're going to do. I'm going to say if, and we've already got current time from get tick. So we have a last time, remember, and we have a current time now. So current time needs to be bigger or equal than last time, right? If it is, then we have a good time, and I'm going to say the elapsed time is going to be current time minus last time. I'm sure their SDL has some built-in way. I don't know. I just already knew how to do this, so I just did it myself, but there's probably other functions that do this. But I can just say current time minus C last time. So again, what's happening here is if my last time was set at 88 ticks and my current time is 90 ticks, right? So I can take the current, which is 90, and subtract the last time, which is 88, and I'm going to get 2 ticks have passed, right? But this won't work if we've rolled over. If we are at 99, and now the current one is at 1 tick, well, 1 minus 99 is not 2. So we have a problem there. We have to think about it differently. So if this is not bigger, that we've had that rollover occur. So what we want to do is I want the biggest number that can happen in this unsigned 64, right? I'm going to say elapsed time, and I'm going to take this I'm going to cast -1 to a uint 64. Okay. So what -1 is going to do is -1 is going to end up in an unsigned integer. It's going to end up being the largest number possible. So if I take a 0, a 0 is a 0 if it's signed or an unsigned integer. But an unsigned integer doesn't have negative numbers. Those negative numbers are actually bigger numbers. So what's going to happen is the -1 is going to be the absolute largest, and then -2 would be the second largest number, and so on. So if I just take a -1 and I cast it to uint 64, I get the biggest uint 64 number I can possibly have. And I'm assuming a rollover has occurred, right? So what I'm going to do is I'm going to take the biggest number that can happen. I'm going to subtract from it the last time, which is before the rollover. The time that we got that was before the rollover, right? And then I'm going to add to that the current time. Okay, so here's the idea. If a rollover has occurred, say we're at 99, and then a rollover occurred, so our new time is 1, right? So what can we do? Or let me pick something other than 99. Let's say 95, right? And our new time is like 2, right? So if we're at 95 and our new time is 2, well, that would be 96, 97, 98, 99, 0, 1, 2. So that's 7 ticks have passed, right? So if I were to take the largest number possible, which is 99, and I subtract 95 from it, and then I add here, so this is going to give me 4 plus 2, which is 6. So maybe my math is wrong. Yeah, 4 plus 2 is 6. 99, yeah. What did I say? That is right? 95. Oh, well, this is giving me the number versus how many have gone by. I don't know. I could be off by 1. Anyway, this is going to be correct. That's the idea here. So the biggest number possible with the last one. So that gets us up to the rollover. And then we're adding to it after that what's occurred after the rollover. So that still gives us our delta time, even if a rollover has occurred. And it's very unlikely that a rollover will occur because this is a uint64. And I don't remember what this is, but it's I don't remember if it's like thousands of years have passed or something. I can't remember. The amount of time that needs to pass before this rolls over is a very large amount of time. So probably won't happen, but I just want to make sure I'm doing it correctly. So we have this elapsed time, but what we want to know, has the elapsed time bigger than 1,000? If it's bigger than 1,000, then a second happened, right? So if elapsed time is bigger than 1,000, I should have said bigger or equal. That's probably more accurate there. Bigger or equal to 1,000. Then what we want to do is we want to update the last time to the new second last time. Well, we want to take seconds. We want to update those, right? So seconds, a second has occurred. So I'm going to plus that. And then we want to update our last time. And I'm not going to do ticks on it. I'm going to plus equals 1,000. Because again, we could be past the threshold by 5 ticks or 50 ticks or whatever. That means if I were to reset it then, I would be off. My second would have lasted too long. Now, the indication of the second might not be perfect, but the next second will still be in the correct spot. So that's why I'm doing it this way and not getting ticks again for the new last time. This keeps me on track. But now that we've changed the seconds, we need to call our function again, which is clock update digits. And we have a problem up here. Okay, so this is our function to update the time. And we do need to, call this. So let me just check if I'm resetting into. Okay. So in the beginning of the game, I'm not actually resetting. I should be, but I'm not. So I'm going to do that instead. So up here at the top, where I'm calling this, I'm going to call reset instead. That seems better. They both kind of do the same thing, but this does seem a bit better for me to just call reset. I haven't forward declared these functions. Just getting rid of that. I need to forward declare them, the 2 functions that we just added. So there is reset here. It's just complaining because I haven't forward declared it yet. And this update one. So I'm going to grab both of these. And they're going above. They're going to go underneath here. And unfortunately, they don't actually go here. They go into the header file. So after I clean this up, I'm going to move them. Okay. So they don't go here, actually. They go into both reset and update are going to into the header file above the draw function right here, because I need to use these from game as well. Okay, so now this shouldn't be complaining. This all looks good. So in game, it's already going to be reset when I do the new, so that's fine. But on game reset, right down here, I do want to reset the face, and we didn't do that before. So the G, what is it? Sorry. The function for face default is going to be G face. That's kind of resetting our face just in case somehow it's not right. And also this clock reset. There. So that's going to reset every time we reset the game. The clock is going to reset, and it's going to get its new timestamp with the get ticks for the last time on it and set it back to 0 and reset the digits and all that stuff, which is great. Now we need to we need an update. So in game, down here in game run, I'm going to put it above draw. We need a new function here, which is just basically game update. Move this out of the way. Sorry. So it's just going to be a very basic, where am I? Not right. Let me look at my notes. So right above draw, it's just a basic function. It's just calling update of time, but only if is playing is true. So void game update. And this is going to be just struct game G. And if G is playing, then we're just going to say clock update G clock. And that's basically our function. We are going to forward declare this one now, and it just added something. Okay, so I'm going to forward declare this. This is right above draw. Okay, we have that created, but we didn't actually call it. So we need to call it from the game loop. Right here, right before draw, we're going to do game update. And that should be fine. Nothing fails there, so that's all fine. Okay, so we should have a working time. Okay, looks pretty good. I'm going to let it go over 10 so I can see if the 0 and all that stuff is working correctly. Okay. And I'm going to cheat a little bit because I don't want to watch the clock tick by, but I do want to see it in the bigger numbers as well. So I'm going to go in here into the function right here. And I'm going to add 99 onto this. So it's going to start out at 99. It's always going to have 99 extra seconds. It's just so I can test. It looks fine. It looks like it's all being displayed correctly. Okay. Let's try bigger number. Maybe 9. So I'm going to go 899. Okay. And lastly, I'm going to go say 989. And I don't need to compile the whole thing. I keep compiling the whole thing with the clean. It's because I was jumping between different folders that I was compiling code from. This should stop at 99, so that's what I'm looking for. Okay. Oh, That's not right. That ain't good at all. Houston. Okay, so yeah, that's a bug. Gotta figure that one out. Okay, so it looks like seconds should be dealing with this. If seconds is bigger than 99, then seconds is 99, right? So let's say C seconds, and we'll just do a D on that, and then seconds, we'll do a D on that. I think that's correct. Oh, this is a problem I've created because I've added artificially. This is my fault. Hold on. Instead of doing it here, I'll do it on the reset. Where's the reset? I'll put it here. 989. How about that? Yeah, I don't think there's a bug. I think that's just me looking at it wrong. Yeah, see. So we're at 1,003, 1,004 seconds, but our seconds variable, our local one, just keeps saying 999, 999. And then it gets converted, correctly. So that's a way. On this other one here, we can actually go with the negative numbers. So I block it to 999 on the positive, and then negative 99 on the negative when we're doing the indication of the mines. So that's something to think about as well. Okay, so I'm going to fix this. And down in, of course, we added the print statement right here. Okay, so that looks all like it's working. So let's just cover what we've added here. So we've basically added this just for the digits just so we can separate the seconds into 3 different decimal positions. So we have this digits array of 3. We also have seconds that we're keeping track of, and we have last time that we're using with the get ticks. Okay, so right away in the top, we are calling reset. So when the game starts, we're just going to use the reset function. And anytime the game resets, we're going to use it as well. So we're calling that reset. So this is the new one. This is all about breaking up whatever the seconds are into the 3 digits. So right here, I'm just using this ternary. If it's bigger than 99, I'm going to take seconds and divide it by 100. And this is going to give me, since this is not a double or a float, it's actually a unsigned int, it's going to give me whatever's in the hundreds position. And if seconds is not bigger than, if it's not 100 or more, then it's going to give us this 11 image, which is actually the placeholder one. And we do the exact same thing for the other one, except we need to divide it by 10 and then do a modulus 10 on it. Okay. Or if nothing is in the slot as well, we still have the placeholder. Yeah. And then the final last one, we're just doing modulus 10. Yeah. And putting in there. So that just gives us our first decimal place. Okay. So when we do a reset, we're getting whatever last time is, we're counting our last time so we can count if 1 second has occurred after that. We're doing get ticks. setting that last time. We're setting our seconds to 0, and then we're calling this function right here that should do placeholder 0. Hopefully that's what it's doing on the reset there. And then the update function, it's getting our whatever our current time is, because this function could have been called, half a second ago. And now on the game loop, this function is being called right now. I'm getting the current time. I'm just creating a last time placeholder, and this is all about checking for rollover, and I'm trying to get the delta, the difference between last time and current time. So we're calling that elapsed time. So it's current time minus last time. Unless it's rolled over, then it's the biggest number minus last time plus current time. Once we have that delta, we see, is it bigger or equal to 1,000? That means 1 second has passed. If it has, we're going to bump the seconds. We're going to add 1,000 onto our last time, so we have a new last time. And we are going to call our clock update digits again, this one up here, that resets up those digits. We've also changed it in this clock draw right here. This used to be a 0, but now we can use our array that has 3 different items in it, and this loop is looping through the 3 different spots. So we can say for each one of those, grab the digit that's in that position, and draw that one. This corresponds to the source rex, which corresponds to these. So if a 0 is in that position, we see a 0. If a 1, we see this one. So, and if it's 11, we see this guy over here. Okay, so I think that's it. Up in game, we have added a new function, and we have forward declared. So we have 3 new functions that we've added here. One of them is just locally used, so we're forwarding it, declaring it up above in the source. The other 2 need to be called in game, which is the reset and the update, so that they are in the header file. Clock H. So their reset and update are in the header file here. And in game, the new automatically calls the reset, so nothing needs to be done there. But on game reset, we did forget before just to make sure the face had been set back to the default face. But we're calling clock reset on that as well. So we can reset the clock anytime the game is reset. But that doesn't help the time tick by. So for the time to tick by, we had to create this new game, this function right here. And this only gets called if is running. So when game is over, let's check that real quick. So our clock is running, and I'm going to start playing, and I'm going to, since it looks like I can win easy, I'm just going to win easy to test the win version. That's all 3 right there. There we go. So the clock did stop on the win. Okay, let's see the clock stop on the lose. And the clock did stop on the lose. And it is resetting, and it's counting correctly. Okay, so we've checked all those. So all this does is call the clock update, which is just checking the seconds and updating that array. But only, again, if it's in the is playing state. So we've created this function here. We forward declared it, or we've set the signature up here for the update. And then down in the game loop, we are calling it. So we're doing events, update, then draw, and then we have our 16, millisecond delay there. Okay. So I think that's everything. Nobody asked any questions. Oops. Yeah. So that's everything. I hope you enjoyed that or is entertaining, and I'll see you in the next one when we add the indicator for the mines. Thank you, and see you in the next one. Bye.